Now let's talk a bit about the semantics. Now there's a symbol called V with a trace on the top, and this means total valoration, right? And what this means is whenever we have a formula, for example, let's say this one, if we have a symbol of total valoration preceding it, it means that it wants us to execute the formula, right? So, for example, if we have some question like A, right? And it tells us that, you know, V negation of sigma, phi, sorry, is the negation of this is a truth, by the way, is the negation of V again. So yeah, we can bring this one outside, right? And those will be equivalent. When we put this symbol before, it means that there is no suspended times or animation or an awaited evaluation. It means it is immediate. When we put this, this represents the evaluation of what is contained following it. So in this case, if we give, you know, 5, we give it 1, then the negation will make this expression 0, and the total valoration will be 0. The same can be applied here, so like it's a transitive. So in this case, if this was 1, right, and the valoration we want it, so it would become 1, and then the negation of the valoration would be 0, and we obtain the same result, thus given the equality. And that's why this is also a truth that holds. Pardon me. Let's give it another example. Let's say there's a problem B. Let's say that B asks for the total valoration of this formula, whatever it may be, and this formula, right? We can also do something here. We can decompose it into two sets of valorations and bring the connector, the logical connector outside. So we can do this, excuse me, the valoration of this as well. Those mean the same thing, as well as we could for example, the opposite. I mean, you can see it from here, right? But like if we shifted them, we could say that the valoration of a set is also equal to the transient. So you can join them or separate them as you wish. This also holds for, okay, let's give a final example for any other logical connector. Let's call them, so imagine V, the valoration of 5, yeah. We could do the exact same thing for any connector. Well, except for, no, any connector, yeah, no exceptions. Exactly, like this. So an implication can also be separated as you can see. It's pretty cool. However, we have to keep one thing in account, which is that these formulas that we are using across these, let's say they all belong to the A, the A problem. Because we're using the same symbols and the same types of operations, we must also preclude that these formulas, right, their valuation of phi and also the valuation of the symbol, they both have to belong to a certain arithmetic, right? So they can't be both true. Sorry, it can't be that one is using the nomenclature true and the other one is using I don't know, pizza, or let's say okay, let's say 1, right, or 0 or 1. It has to be true. It has to be matching. So if this evaluates to true, this has to evaluate to true or false. Okay, so true or false. Otherwise, the logic is corrupted. It can't be used in such a manner. However, there are certain exceptions. Like if let's say, for example, if we in this field of logic, we can have certain an implication, right? Let's say that true implies 1, false implies 0, or equates, and then we can use the and let's say, okay, we could use true equates pizza, and false equates burgers or burger. Multiplicity is also a concern here. Okay, but yeah, we can specify these equalities and then we can match pairs. So when we say that they have to be matching, the exception is that if you make them equal. Another thing that we can say, actually this is just semantics. We can call sorry. We can call a valuation without the trace on top. It becomes something we call a model. Okay, so the symbol of the valuation without the tick is a model, and whichever propositional formula we have inside, if it turns out to be 1, then or true, or any positive indicator, then it is said to be satisfactory, a satisfactory model. So satisfactory. And let's say, for instance, this model is 0. It's called a unsatisfactory or contradictory. And if we want to be semantically precise, as correct as possible, we will just call the first one a model because it is satisfactory, and the second one will not even be called a model because the total evaluation will be contradictory. But we can say it both ways. It's just a matter of context. That's about it.